So in this video, I'm answering the question of how do I solve for nCx, or n with the big C and then x. My answer to that question is I don't think you need to. So I haven't found any problems in Newton where you would actually need to solve for that. Now, some of the problem explanations get into how to solve for that, but you can much more easily solve it if you just use binompdf or binomcdf. So remember, we use PDF, and that's the formula on our formula card. We use PDF when we're doing the exact number, and then we use CDF if we're doing that number or fewer. And then if we're doing more than that number, we just kind of refigure our number line until we get what we need, find the complement and that kind of thing, just like we did in class. Here we have 65% of the people in Missouri pass, and so that's our probability of success. P is 0.65, and so here binomcdf is the one I used, and I'll explain in a minute why I use CDF. But 0.65 is our probability of success, n, p, x. And then it says a group of 5 people, so that's where I got my n, 5. 5 people are doing the test. What is the probability that less than 3? Less than 3 is the same thing as 2 or fewer, and if you drew it out on the number line, you would see less than 3 doesn't include 3, but it does include 2, 1, and 0, so 2 or fewer. And because it's 2 or fewer, we want to use CDF, because again, we go to our formula card, this number or fewer means we want to do CDF. And so we just plug in binomcdf, n, p, and x, and we get 0.235. And that's the exact answer. We don't need to do anything else. We don't need to do all this crazy stuff of n choose x and p to the x power and q to the n minus x power. We don't need to do all that. binomcdf does it all for us. And really, they have to do it 3 times because they're doing, this is essentially binom PDF for 0, and then for 1, and then for 2. You don't have to do it 3 times. You can just do binomcdf, and it'll do it all for you. So the reason we didn't do that in class is because I don't think you need it. If you can show me a problem where you need it, though, definitely I'll go in more detail. But let me just show you real quickly how to do it. So when you do 5 choose 0, you can do that on your calculator. That's how we read this right here, 5 choose 0. So when we do that on our calculator, we just hit the 5 first, and then we go to math and scroll to the right until we get under the probability menu, and then we do NCR. NCR is the same thing as nCx, essentially. And so we hit option 3, and then see, it looks just like that even on my calculator. And then I do 0 because I'm doing x equals 0. And then I could just, in the same line, if I wanted to, oops, I need to delete that. I guess I need to go up, the up arrow. Oh, that didn't help me. I need to go right to get it on to multiply by 0.65, and that needs to be raised to the 0th power, and then I guess I need to go right again, and then times 0.35, and that needs to be raised to the 5th power, and that should give me approximately 0.005. Although I'd like to keep more than one significant digit, obviously, on this one. And there we go. And then I could do second enter, and change the 5 to a 4, and the 0s to 1s. So I think that's 5 choose 1, 0.65 to the first, 0.35 to the 4th. Okay, and then I get 0.04. Oh, they only gave 2 significant digits. They're not giving very much significant digits on there. And then I could do the other one. But see, I'd have to do all of this and then add all those together. when all I could do is binomcdf. So hopefully that answers your question, and you'll use binomcdf and PDF instead of this stuff. But if you need to do that, then again 5, and then math, prob, option 3, and let's do 2 this time. And I'm just going to hit enter. I'm not going to do the whole thing. So that gives us 10. So if we did it by hand, that would mean 5 factorial, 1 factorial, and then 5 minus 1 factorial. And then you'd have to do all the factorials and cancel them out. It's just a mess. So, instead of doing all that, do the binom PDF or CDF, or the complement in some cases of binom CDF.